Hello, my name is Armin Zambrano. In this presentation, which is very unscripted, I'm going to be talking about Mozilla's continuous integration. The reason I'm doing this is because there is a lot of moving pieces under our continuous integration, and for people who are not part of the teams that build this continuous integration, it can be sometimes challenging to grasp how to make changes to it or how it actually works. In this case, I have a project called Mozilla CI Tools, which has been built at the beginning of 2015 in order to actually manage these different parts inside of the continuous integration. Now, the main view for a developer, before I continue, I'm just gonna try to go as I go, and I'm going to make mistakes for sure. So please bear with me. I'll hopefully at least the time will be useful, even if I make mistakes here and there. Now, when developers push their code to various repositories, in this case, we're talking about a repository called Mozilla Inbound. When they push their code, it lands initially on the HG servers. So we can see over here there is a repository HG Mozilla Inbound, and that gets picked up by the product called Treeherder. Now, Treeherder shows over here which chain sets are new to Treeherder. They have not been seen. They have not been seen before. Now, we can see that a previous person pushed this chain set, and after him, another person pushed these two. Now, I'm not going to go into the details about how Treeherder displays certain things and why, but over here we see a lot of jobs or letters that represent builds and unit tests and performance tests. Now, over here we can see that there are some builds. Some of them are actually running. You can see there is a dark gray. Some of them are pending, meaning that they have been scheduled, but there's no machine available at this moment that is actually running the job. So we could click, let's say, on a pending job, and we can see that it's been I assume it's been 9 minutes since the job actually had been scheduled. Anyways, I'm gonna close this again. Now, there is a lot of jobs on every push. If you look at this over here, it says 278 in progress. That shows how many jobs are running at the moment, and you also see a percentage showing how many of these jobs have been completed. In this case, the most recent push, there's 15% of the jobs completed. Now, there are two different continuous integration systems that two main continuous integration systems that report to Treeherder when a developer pushes a change. One of them is called Buildbot. So let's look for Buildbot. So Buildbot is this continuous integration system, and Release Engineering has have built this a few years ago with Buildbot. Now, there is another one underneath called Task Cluster, which is the new one that has been in the works for the last year or two, and there's been a lot of B2G or Firefox OS jobs that have been using Task Cluster for a while. Now, at this point in time, at the end of 2015, we are trying to transition some jobs that are running on Buildbot. We want to transition them all the way to tools to Task Cluster. Now, over here in Treeherder, any of them look the same. There is really no difference, right? But if you type in here the letters TC representing Task Cluster, we can see that there are some jobs in here running which are actually executed on the Task Cluster side. Now, if we remove this filter, you will barely be able to see you won't be able to see the difference between Task Cluster jobs and Buildbot jobs. Now, how can we see the Buildbot jobs? there is a tool called Build API, which sits in front of as you can tell, I cannot multitask when I'm thinking of a password or answering a question. But in any case, you've seen that I've reached a server. We call it Build API Self-Serve. Now, this Build API Self-Serve shows you that there can be a section with pending jobs. This section we see all of the running jobs, and down here we see all of the jobs that have completed. Now over here we see some other forms that allows us to interact with the CI. We can cancel all the running builds. We can create a new nightly PGO build or dependent builds. I won't get into the details of what each of those are. What matters is that you can trigger things over here and you can make them show up over here. Okay, so we can even cancel individual jobs and rebuild jobs from here. However, some of these is already implemented from here. I could click on a job. I could cancel it if I want to. I can retrigger it. Retrigger means it means run it again. Now, something I want to point out over here is at some point we're going to be switching from Buildbot to Task Cluster. And we have tools like Mozilla CI tools that need to interact with both of these systems. Now, let's look at a little bit of MozCI and see how it works. So under MozCI, we have a folder called Sources, which we're going to look into it a little bit. There is the main MozCI code, platforms, query jobs. So for instance, let's look at CI Manager. On CI Manager, we have a main class called Base CI Manager, and there are some methods that need to be implemented. Schedule an arbitrary job. Now that we have looked at over here, let's try to see what that means over here. Let's say let's look at Mockitest, for instance. For instance, this one. If we look at this failing job, is orange because there's been some sort of failure. We can look at the details about this job. In this case, it's a Mockitest browser Chrome 4. Now, if we look at on the job details, we can see a very long name. It says Ubuntu VM 1204. 64-bit architecture for this repository. It's a debug type of build, and debug because it's running against a debug build. It has and a suite name. Okay, so now when we imagine this push on Treeherder did not have this job running, we would then schedule an arbitrary job. For Buildbot, it's as simple as you will have to excuse me for a second. Now, we created a separate tool, our Python package called Build API Client, which specifically deals with scheduling through Build API. Now, Build API has various APIs. Okay, there is over here one called yeah, it doesn't matter, it doesn't have a name. It's on the builders. We specify a branch, which is the repository name, a builder name, and a revision. So under the build API client, over here we will have to specify the repository name, a builder, and I'll explain what a builder is. Buildbot has many builders associated to it. A builder is simply a type of job. In the case that, in the way that we implemented it for release engineering, an actual job over here, which has a builder name, is unique. It's almost as a unique identifier. So in the build API code, we will pass on the builder parameter to it, revision, authentication for build API, and that would schedule a job on Buildbot. Now that Buildbot job will eventually show up on Treeherder. I'm going to leave out how it shows up on Treeherder. I will deal with it on a follow-up video because I want to wrap up this one at this moment. Now, we have seen how to schedule a job on Buildbot and how it would show up over here. But now with Task Cluster we have a different way. Let's look at it. With Task Cluster jobs, let's see, which one could we look at? Things are a little different. When we go to job details for a job from Task Cluster, we don't actually see all the metadata. We'll see more things as time goes by, but instead we will be able to reach tools.taskcluster.net, and there is a unique identifier for that job, in this case that, and we can inspect the job. There is a live output over here. It also shows which artifacts or files that have been uploaded by this task. And there's something very important over here to understand. A task, you can schedule a task completely independently, or you can schedule it as part of a graph composed of various parts. One of them is a dictionary of tasks, or a set of tasks, and they are all interrelated, or they are all related by task group ID. Now we have gone now to Task Graph Inspector. All of those tasks are related. I don't know what my browser is doing. If there was a way to freeze this. Anyways, we have loaded a task graph. We're inspecting it, and over here you can see all of the jobs that were scheduled on that push. Each one of them are specified over here. However, they don't have unique names as you have in Buildbot. This is simply a description, but you can have two Mulet-Gaia.js integration, yet both of them being different or having different parameters. Okay, so one thing to understand from Task Cluster is that things get scheduled from the tree, from within the tree. What does that mean when I talk about within the tree? If we look at over here, somebody has pushed some code in the what we call the Gecko tree. Gecko is simply a rendering engine that we use for Firefox, and we call these the Gecko repositories, or Mozilla Central, or Mozilla Inbound. All of them are related. Now, there are jobs in here scheduled that have been scheduled either by Buildbot or by Task Cluster. The ones that are scheduled from Task Cluster, we can actually have control over it. It's called the Gecko decision task. Before any Task Cluster task gets scheduled, a Gecko decision task will be scheduled. The Gecko decision task will simply determine what does it need to get scheduled on this push. It's going to do analysis of various sorts. It's going to look at what Llamo files, and I'll talk about what Llamo files are specified in the tree. If I find it over here, yes, over here at the bottom, you see a .mac task cluster graph, push log ID, message, project, owner, revision hash, extend graph. So the Gecko decision task, all that it really does is execute that command. And if you check out Mozilla Firefox's or Gecko's repository, you can actually run this command. And that command will actually generate JSON file or JSON output. And that JSON output will be, if I recall correctly, somewhere in here it will be redirected to a file, and that file will contain a graph with all the information of which jobs have to run, and they will be scheduled. Oh yeah, over here you see a graph.json, and that's a task graph ID. So we can see somewhere in here, I'm sure if this stops refreshing. Let's see. I would have thought the Gecko decision task is here as well, but it could be simply an independent task which creates a graph and it doesn't belong to it in itself. Anyways, how does task cluster determine this? First of all, the mac command is down here, and that will load stuff from here, and you will have tasks in here defined. In this case, let's load a Llamo file, and these are the Llamo files I was talking about earlier. And inside of a Llamo file, you can specify a lot of metadata about the job. And something I didn't point out over here is that there is inheritance between Llamo files. That means that the final JSON task representing the actual Llamo file, it will be generated by multiple Llamo files being analyzed. For instance, the monkey test browser Chrome inherits from this Firefox unit test base, and there is a command here specified, and some of these values are going to be replaced. I think I have gone a bit deep in this first introductory video with regards to how jobs get scheduled on Treeherder via either Buildbot or Task Cluster. And for now I'm going to leave it at that, and I'm going to ask for what would people prefer seeing. So what we have seen so far is on Treeherder there is a lot of jobs. Some of them are scheduled by Treeherder, by Buildbot. Some of them are scheduled by Task Cluster. Both Buildbot and Task Cluster have different ways of interacting with it to schedule more jobs. In the case of Buildbot, it's something called Build API Self-Serve. In the case of Task Cluster, I will show you. There is a Python client called Task Cluster Client, or simply a package called Task Cluster, which we import as Task Cluster Client. And we can create tasks, and we can use that to schedule it. We simply generate a JSON object. And once we create a bunch of tasks, we can create a graph in itself. We create over here an ID for that graph. We create over here a scheduler. And once we have the object that we pass is a task graph, and we simply schedule it. And that will, according to the variables that you have set up in your Llamo files, will actually show up on Treeherder or not. I think that's good for now. Billboard schedules things either through Build API or its own Billboard scheduler, but I believe this is a good start on how what is under the hood when it comes to Treeherder and the different continuous integration system there is over here. I hope this was interesting, and I apologize if I go all over the place and I didn't have a clear path. This is just an experiment, and we can redo it later on with something more structured if people would like to see that. Thank you for listening.